Welcome back to the course on machine learning using Python programming. In the last class, we have studied KNN for classification, and in this class, we are going to see another machine learning model, that is naive Bayes for classification. So, in general, we will see what is Bayesian classifier, and naive Bayes is one of the Bayesian classifiers. So, Bayesian classifiers are statistical classifiers, and they predict the class membership probabilities. We can say that it will give you the probability of a particular class. As a result, we will predict the class for which the probability is the highest probability. So, Bayesian classification is based on the Bayes theorem. So, what is the Bayesian classifier? Definitely when the relationship between these dependent and independent variables is non-deterministic, then we use these classifiers, or we can say that this relationship, statistical relationship is there, then we use Bayesian classifiers. So, suppose you are having in your data set few instances, and for all these few instances your independent variable values are same, even then your dependent variable values may be different, because there may be some confounding variables that are not in the data set. And so, you can say that this relationship is a statistical relationship, and that is why here we use some probabilistic techniques, that are Bayesian classifiers we use for classification. Now, we will see naive Bayes classifier, that is one of the example of Bayesian classifier. So, again it is a probabilistic machine learning model, and naive Bayes classifier is also called as simple Bayesian classifier. Why it is called as simple Bayesian classifier or naive Bayes classifier? We will see that we take some assumption, because of that your Bayes classifier is naive, or you can say that if that assumption is followed, then only you will get the better correct results. That is why it is called as naive Bayes classifier or simple Bayesian classifier. So, we have discussed that all the Bayesian classifiers are based on Bayes theorem. So, let us first see what is Bayes theorem. So, Bayes theorem is probability of y given x is equal to probability of x given y into probability of y upon probability of x. So, what it means? We are saying that probability of y given x. So, we are already knowing when this is the case, this is true, then what is the probability of y? So, we are calculating the probability of y conditionally for this x, and it is defined like this: probability of x given y into probability of y upon probability of x. So, how we will use this Bayes theorem for classification? So, we can see one example. Suppose this is a data set where this is a data set of few persons, where age is one of the independent variable, and estimated salary is salary is another independent variable, and there is some product, whether the person have purchased that product or not. So, that is represented as a purchased attribute. So, when its value is 0, it means that person has not purchased that product. If it is 1, it means the person has purchased that product. So, now we can say that based on the age and salary, the person may or may not purchase the product. So, we want to learn it. Now, if we learn this from this data set, for any new person, we can predict whether the person would be interested in purchasing that product or not. So, how we can do it using Bayes theorem, or how the naive Bayes classifier works? What we do, suppose x is the instance for which we want to predict its class. So, whether it will belong to class 0 or it will belong to class 1, means whether this person will not buy the product or will buy the product. So, these it will this person, that is a new person. So, here x1, x2, x3 up to xn are values of independent variables. So, in this case we are having only 2 independent variables, but in general there in your data set there may be n independent variables. So, in general it is written as x1, x2, x3 and so on. So, now we can say that how the classification will be done here. We will calculate probability of y given x1, x2 up to xn. So, this is the person and all the features of person is given, and then we are saying what is the probability that y is 0 for that person given that person, and then we will calculate what is the probability that y is 1 given that person. So, if we can find out these probabilities and the probability that will be more, we will assign that particular class to that person or that instance. So, now we can say that probability of y is equal to 0 given x1, x2 up to xn can be written as probability of x1 given y, probability of x2 given y up to probability of xn given y into probability of y upon probability of x1, probability of x2 up to probability of xn. So, this is written, this is nothing but the Bayes theorem as we have seen. So, in case of x is written as x1, x2 up to xn, and here in case of naive Bayes classification, the assumption is that all these independent variables x1, x2, x3 and so on, all these independent variables are independent to each other, and that is why probability of x can be written as probability of x1 into probability of x2 into probability of xn and so on, or probability of x given y can be written as probability of x1 given y into probability of x2 given y and so on. So, by taking this assumption, it is very easy to calculate probability of x or probability of x given y, and that is why it is called as naive Bayes classifier. So, here we are assuming that all the independent variables are independent to each other. So, if this assumption will be satisfied, then your generally naive Bayes classifier works very well, you will get very good predictions. But if this assumption will not be satisfied, in that case your predictions will be wrong. That is why it is always necessary to check whether this assumption is followed or not. Now, we have seen that when we are calculating probability of y is equal to 0 given x1, x2 up to xn, then right hand side is this. When we will write probability of y is equal to 1 given x1, x2 up to xn, then right hand side will be probability of x1 given y is equal to 1, probability of x2 given y is equal to 1 up to probability of xn given y is equal to 1. It is better to if I am writing it here, it will be better. So, we will calculate it probability of y is equal to 0 given x1, x2 up to xn. How we will calculate it? We will calculate it as probability of x1 given y is equal to 0, probability of x2 given y is equal to 0 and so on into probability of y upon probability of x1 into probability of x2 into probability of x3 and so on. In the same way, we will calculate probability of y is equal to 1 given x1, x2, x3 and so on up to xn. How we will calculate it? Same expression, but probability of x1 given y is equal to 1, probability into probability of x2 given y is equal to 1, so on, into probability of y upon probability of x1 into probability of x2 into up to probability of xn. So, we can see that denominator in both of these two cases is same. So, when we are trying to calculate this probability and this probability, so only numerator is deciding the difference between these two. Denominator is same. So, we can leave denominator, we will calculate only numerator, and based on that we can find out whether probability of y is equal to 0 given x is less than probability of y is equal to 1 given x, or the opposite is the case. If probability of y is equal to 0 given x is less than probability of y is equal to 1 given x, we will assign class 0 to this instance x, means we are assuming that the person will not purchase that product. If probability of y is equal to 0 given x is greater than probability of y is equal to 1 given x, in that case we will assign, in the previous case this was better. So, we will assign class 1 to x. In this case probability of y is equal to 0 given x is greater than probability of y is equal to 1 given x. So, we will assign class 0 to x. So, this is the basic idea behind naive Bayes classifier, and it is written in this way: y is equal to argument max y. So, we are predicting that y, that class for which this probability is maximum. So, for which probability of y is maximum. So, in this way we calculate so what is the probability of y? So, this is the right hand side of the previous expression, probability of x1 given y into probability of x2 given y into probability of x3 given y into probability of y. So, for y we will find out the y for which this expression is maximum, means y for which probability of y given x is maximum. So, this is nothing but probability of y given x. So, if it is greater than if it is maximum for 0 value of y, we will assign 0 class to x. If it is maximum for 1 y, then we will assign class 1 to x. So, this is the idea. Then we can say that Bayes theorem, let us see some facts about Bayes theorem. So, Bayes theorem is named after Thomas Bayes, and this is a statistical principle for combining prior knowledge of classes with new evidence gathered from the data. So, it means we will have some prior knowledge of the classes. So, we are trying to predict class of a new instance. So, we are already having some prior knowledge of the classes, means what is the probability that the class may be 1, what is the probability that the class will be 0. So, there is some prior knowledge of this, and then based on the data, based on the new instance that we are getting. So, new instance is x1, x2 up to xn. So, based on this new values, we will try to update, we will try to get a posterior probability of y. So, what will be the actual y? So, we are updating this prior probability by seeing some new data, and then we say that we are getting the posterior probability. So, we say that your new the instance x for which we want to predict is called as the evidence. So, you are having now evidence, you are having now new data, new evidence, and based on new evidence we are trying to find out, we are trying to update the class probabilities. So, we can say that sometimes we say it as probability of H given X, where H is the hypothesis. So, your hypothesis may be the class of X is 1, means Y is 1. The hypothesis may be the class of X is 0, means Y is 0. So, if it is a multi-class classification, in that case your hypothesis may be your class is class of X is 2, so Y is 2. So, means it is written in terms of hypothesis, and the hypothesis is nothing but that you are define your one hypothesis is for each class. You will define different hypothesis for different classes and then check which hypothesis is the best one. So, the posterior probability, as we have seen that we are finding probability of H given X. So, this is the Bayes theorem, probability of H given X is equal to probability of X given H into probability of H upon probability of X. So, this is the prior probability of hypothesis, this is the posterior probability of hypothesis. So, posterior probability, how we are calculating using prior probability and using this probability. So, we can leave this because for all the hypothesis this denominator part is same. So, we can leave this, but these two will be used here. So, we have seen what is prior probability and what is posterior probability. So, this is the Bayes theorem that we will use in case of Naive-Bayes classification. So, this is the crux of the Naive-Bayes classification. Now, it is written in terms of classes. So, sometimes what happens, as we have seen, we will calculate probability of you can say probability of Y is equal to C1 given X. You will calculate probability of Y is equal to C2 given X, you will calculate, and we have assumed that since we know that denominator is same. So, we will calculate only probability of C1 given probability of this we will calculate as probability of X given Y is equal to C1 into probability of C1. This we will calculate as probability of X given Y is equal to C2 into probability of C2. So, now what we are assuming here, sometimes we assume that for each class, means for any instance belonging to any class is same. So, we are assuming probability of C1 is equal to probability of C2 is equal to up to probability of Cm, where m classes are there. So, in that case we will calculate this probability using only the first expression, but if this probability is different for all the classes, in that case we must incorporate this also in calculating this probability, and based on that we will find out what is the class for new instance X. So, now how we can find out this probability of C1 or probability of C2 or in general probability of Ci, how we can calculate it for the given data set. From the given data set we can calculate probability of Ci's. How we will calculate it? This is nothing but suppose let us see this example. So, you see in your data set, suppose 0 is corresponding to C1 and 1 is corresponding to C2. So, these are the two classes. So, how we will calculate probability of C1 or how we will calculate probability of C2? So, we will calculate it, they are total 5 instances, and out of these 5 instances they are 3 C1 instances. So, probability of C1 will be 3 by 5, probability of C2 will be 2 by 5. So, from the given data set we can always calculate these probability of CIs. Now, we will see how we will calculate this one, probability of x given y is equal to C2. So, we have already seen by the assumption that all the features, all the x1, x2, xn are independent to each other. So, this can be written as probability of x1 given C2 into probability of x2 given C2 in up to probability of xn given C2. In the same way we can define this also. So, now we can calculate probability of x1 given C2. How we can calculate probability of x1 given C2? So, suppose x1 is some age and this age is suppose young age. So, what we will do, young age. So, what we will do, we will find out all those instances where class is C2. Out of all those instances, how many instances are corresponding to young age or in all the instances where class is C2, in all those instances in how many the value of x1 is young age. So, suppose the number of instances where value of x1, this is suppose young age is that value is suppose n1, and total number of instances where class is C2, where class is C2 is n. So, probability of x1 given x2 is n1 by n. In the same way we can calculate this also. Let us see this by an example. So, this we have already seen that in naive Bayes classification we are taking this assumption class conditional independence, that for a given class its all the independent variables are independent to each other. So, this presumes that attribute values are conditionally independent of one another given the class level of the tuple. So, that is why probability of x given Ci can be written as this. We have already seen this probability of x given, and to make it simple so that we can easily compute these probabilities, we can easily compute right hand side. So, how to estimate this we have already seen, but probability of x given Ci we have seen. In case of when it was categorical, we have seen how we will calculate. If it is continuous, if suppose this xi, so probability of x given Ci, we have seen that we will calculate probability of x1 given Ci into probability of x2 given Ci, Ci and so on. So, if x1 is categorical, then we have seen, so we have seen that x1 is suppose age. So, middle age, young age and old age. So, if we will see for all those instances where class is the ith class, then we will find out suppose for the given instance this age is young age. So, we will calculate the number of young age instances, suppose that is n1 out for all the instances where it was the class was Ci. So, that was total n. So, in this way we can calculate it, but if suppose this age is not this categorical variable, it is continuous variable. If it is written in all the continuous way, numerical values are there, in that case how we will calculate? We can calculate it, but in that case we will need to find out distribution of that variable. So, x. So, suppose that distribution we are assuming it is a normal distribution. So, we must have mean and variance of that normal distribution, and then we can find out probability of x xk given Ci as we will put that value of x here, and we are already knowing mu and sigma for that feature, because its distribution we are knowing. So, we can find out probability of xk given Ci if that xk feature is continuous feature. And then we will see full base classifier. So, full base classifier in that case how it is different from naive Bayes classifier. The main difference is that here we assume that these independent variables x1, x2 up to xn, these are not independent to each other. So, in that case we can't calculate probability of x given y as probability of x1 given y into probability of x2 given y into probability of x3 given y and so on. We can't do like this because we are assuming x1, x2, x3 are not independent to each other, and that is why we are assuming that x is following some multivariate normal distribution. So, what we will do, in your data set there will be some instances that will be corresponding to class C1, another set of instances that will be corresponding to class C2, this is another set of instances that are corresponding to class C1. So, suppose it is binary classification case, in that case you must know the multivariate normal distribution for all these instances and multivariate normal distribution for this also, because all these instances are all these features are not independent, and that is why you must know distribution of these instances, and that is why the number of classes that you have, that many distributions, multivariate normal distributions you will have, and for all those distributions you will have the corresponding mean and variance and covariance matrix. So, using this we can calculate, then if we will get the normal distribution, multivariate normal distribution, then we can calculate this probability. So, this probability is nothing but probability of x given y is equal to 0. So, here we will use multivariate normal distribution corresponding to this class, and probability, when we will calculate probability of x given y is equal to 1, then we will use this probability distribution corresponding to these instances. So, this is difference between full Bayes and naive Bayes classifier. So, in the next lecture we will see one example how we calculate these probabilities and how the naive Bayes classifier works. Theoretically we have seen it in this lecture, but using one example we will see it in the next lecture. So, I am stopping here. Thank you.